On this question it says, without graphing, determine whether the graph of the quadratic function opens up or down. The function we're given is f of x equals negative 6x squared plus 3x minus 1. Now this equation, this quadratic equation, is written in general form. And general form is ax squared plus bx plus c. The value of a is going to determine whether the function opens up or down. In our example, a is equal to negative 6. Whenever a is less than 0, that indicates that the parabola will open down. So for our function, since a is negative 6, which is less than 0, our parabola, our graph, will open down. On this question, it says, without graphing, determine whether the graph of the quadratic function opens up or down. The function we're given is f of x equals 4 plus 8x squared plus 3x. When a function is written in general form, it would be written in the format ax squared plus bx plus c. The value of a is going to determine whether the parabola or graph opens up or down. Whenever a is greater than 0 or positive, the graph of the parabola, the graph of the quadratic, will open up. Whenever a is less than 0 or negative, the graph of the quadratic will open down. So looking at the function that we have, it's 4 plus 8x squared plus 3x. It's not written in general form because the terms are not in the right order. So I'm going to rewrite this in descending order. That means I'm going to put the highest power first. That's 8x squared plus 3x plus 4. And now I can see that a is 8. A is attached to the squared term. A is 8, which is greater than 0 or a positive number, indicating that this quadratic function opens up. In this example, we're going to be given a quadratic function in vertex form, sometimes it's called standard form, and we want to find the following. We want to find the vertex, the orientation, axis of symmetry, intercepts, and then graph this quadratic function. The vertex form, let me write that down for you. The vertex form of a quadratic is f of x equals a times x minus h squared plus k. And the ordered pair hk is the vertex of the quadratic, vertex of the parabola. So our function is written in that vertex form. So after the minus sign, we can see that we have a 4. That's going to be our x-coordinate of the vertex. And then right here we have negative 4, that's the k. And that's the y-coordinate of our vertex. So we have a vertex that is 4, negative 4. The next thing we want to do is find the orientation. And the orientation of a quadratic function is either up or down. The value of a will determine whether that quadratic is up or down. Whenever a is greater than 0, the graph opens up, and whenever a is less than 0, it opens down. In this example, the value of a is 1. We don't see a coefficient in front of the parentheses, so we assume the value to be 1. So a is equal to 1, which is positive or greater than 0, so this parabola opens up. Then we want to find the axis of symmetry. When you have the graph of a quadratic, it's a parabola. And if you draw a vertical line that passes through the vertex, you're going to see that the graph is a mirror image around that vertex. So we call that line the axis of symmetry, that vertical line. So it's a vertical line that passes through the vertex. So for this example, we're going to use the x-coordinate of the vertex, and the vertical line x equals 4 is the axis of symmetry. Next, we want to find the intercepts. I'm going to start by finding the y-intercept. You can find a y-intercept by letting x equal 0. So that's calculating f of 0. That would be 0 minus 4 squared minus 4. 0 minus 4 is negative 4. And negative 4 squared is 16. 16 minus 4 is 12. So we have a y-intercept at the point 0, 12. And I'm going to find the x-intercept. An x-intercept can be found by letting y equal 0. Our equation is in function notation, so rather than having a y in the equation, we have f of x. So we're going to set f of x equals 0. When I do that, I have the equation 0 equals x minus 4 squared minus 4. And I'm going to solve this equation using the square root method. I'm going to isolate this square and everything that that square is attached to. So I'm going to add 4 to both sides to isolate that square. Once I isolate the square, I'm going to square root both sides to get rid of the square. The square root and the square are opposite operations and they cancel each other out. But whenever I square root a square, I gain this plus or minus symbol on the other side of the equation. And square root of 4 is 2. I'm going to add 4 to both sides, and that gives me x equals 4 plus and minus 2. 4 plus 2 is 6. 4 minus 2 is 2. So we have x-intercepts at the ordered pair 6, 0 and 2, 0. Now that I have the intercepts, I'm going to graph this quadratic function. I'm going to use the information that I've gathered. I've got the vertex being 4, negative 4. I have a y-intercept at 0, 12. I have two x-intercepts at 6, 0 and 2, 0. So 4, negative 4, my vertex. I have a y-intercept at 0, 12, an x-intercept at 6, 0, and a y-intercept at 2, 0. When I draw this, I want to keep in mind that these are not random points. The vertex is a very specific point that indicates where the function turns around. We call it a turning point. So this will dip at that vertex and turn around. We also want to keep in mind the symmetry of the parabola. So we should see a mirror image on either side of the vertex. So this gives me the graph of the quadratic equation x minus 4 squared minus 4. Thank you for checking out my videos. Have a great day.